you can't, well, you should always look for the common factor of all three terms. However, x squared, negative 3x, and negative 18 don't all have a factor in common. Does anybody remember what to do in this instance when you're factoring that kind of quadratic? Myra? That's what it is. So if there's no number in front of the x squared, so if x squared is by itself with no number in front of it, what you're doing here is you're looking for what two numbers multiply this number here and add to this number here. So we need two numbers that will multiply to negative 18 and add to negative 3. What's the only way for two numbers to multiply to a negative? One's positive, one's negative. Okay? So we need a positive and a negative that multiply to 18. 1 and 18, right? 2 and 9, 3 and 6. Those are the factors of 18. One's positive, one's negative. And they have to add to negative 3. What two factors are we dealing with? Negative 6 and positive 3? Yeah, I would agree with that because negative 6 times 3 equals negative 18. Negative 6 plus 3 equals negative 3. And so from there, to factor it, you would set up two sets of parentheses. You're unfoiling. That's what this process is essentially. Each set of parentheses starts with x. One of them is going to have a negative 6. The other have a positive 3. And there it is. X plus 3 times x minus 6. And then to solve, you would set each of these equal to 0 and solve for x. If this one gets set equal to 0, you'd subtract 3 from both sides. X equals negative 3. There it is on the graph. If you set this equal to 0, add 6 to both sides. X equals 6. There it is on the graph. So those are our solutions, negative 3 and 6. And we can do that by factoring instead of by graphing. In fact, using the factoring method or using algebra tends to be a lot more accurate than using the graph itself. The graph is a great way to check your answer. It's not always a great way to solve. The last type that we have, well, this is not going to be the last type, rather. This is going to be a different one here. 49 minus x squared. We'll get to stuff like that as we move on. I want to try to find a different one here. Yeah, let's do something like this. So on this one here, you always look for a common factor, but 4x squared, negative 20x, and 25 have no common factor. This time we have a number in front of our x squared. Does anybody remember what to do in a case like this? All right. Here's what I would like you to do. I want you to go to page 167, and I see some room in a margin, and we're going to use that room in the margin. And write down that function in the margin to the right on page 167. Use the lower margin. The top margin only has like 3 lines. We want more than 3 lines here. So actually, I'm going to see if I can do it side by side. Let's try that. We're going to go right here. So 4x squared. So you're going to say, what is this? K of x is equal to 4x squared minus 20x plus 25. All right. Does anybody remember the process for factoring something like this when you have a number in front of your x squared? Because I don't believe that this lesson really goes over the review process of actually factoring, which is why we're doing this right now, because you will have to use this method as we work through it. All right. So there is, it's kind of a weird little name, but we call it the slip and slide method for factoring when you have a number in front of x squared. If there's no number in front of x squared, just do what we did the first time, right? Two numbers that multiply to the last number and add to the middle number. That's not going to work here because we have another number up front multiplying the whole thing. So the first step is to take your value of a. What's our value of a here? 4. And multiply it by the value of c. What's the value of c? 25. So multiply those together. I put a little times above the red arc there. So this is going to give us k of x equals, there's no more 4 here. It got moved to the end and multiplied by the 25. X squared minus 20x. What's 4 times 25? 100. Okay. Now it looks like the one that we just factored. So now we can use our regular factoring process. It's not going to finish the problem, but it'll move the problem along. So we need to find two numbers that'll multiply to negative 100 and add to negative 20. What's the only way for two numbers to both multiply to a positive and add to a negative? They're both negative, yeah. Negative times a negative is a positive. Negative plus a negative is more negative. What two numbers multiply to positive 100 and add to negative 20? Negative 10 and negative 10. Yeah, same number twice. Negative 10 times negative 10 is 100. Negative 10 plus negative 10 is negative 20. So this would be negative 10 and negative 10. And so when we write our next step, we're going to write k of x is equal to parentheses x minus 10 times x minus 10. We're not done factoring them. So this is the part that a lot of people forget to do when they're using the slip and slide method. You are now going to take your value of a, and you're going to divide both of the regular numbers underneath here. Both of the integers get divided by the value of a. So negative 10 in each of these gets divided by 4. Does negative 10 force divide evenly? No. Okay. If it divided evenly, this number would just turn into that number if it divided evenly. However, it doesn't divide evenly. Does it reduce, though? Yeah, to what? No. The 2 and the 5 were right, but just flip it. Yeah, 5 halves. Okay, so negative 5 halves. So I'm just going to cross those out. I'm going to write, well, can I fit that in there? We'll see. Negative 5 over 2. That's fine. Negative 5 over 2. Now, this is the slide part of the slip and slide process. Because we still have a denominator in each one of our sets of parentheses, we are going to slide the denominator in front of the value of x in each set of parentheses. So if you have a denominator, meaning if it doesn't divide evenly, that denominator will slide in front of the value of x, which will give us k of x is equal to 2x minus 5 times another 2x minus 5. And because it's the same thing twice, you could write it as 2x minus 5 and then a squared on the outside of the parentheses. In fact, if we go over here, I'm guessing that's what it's going to show. No, wait, that's not, wow, I'm surprised. I'm surprised it didn't just say squared. So then to solve this, is there going to be a difference between the solutions here? No, because they're the same thing. So if it's the exact same set of parentheses, you only need to solve for one of them. And if you solve for the one here, you'd add 5 to both sides and divide by 2. 5 divided by 2 is 2.5. And look at that. There's only one answer. The vertex is on the x-axis at 2.5 or 2.5. And there it is. So that's what we got going on. Now, if we go back one real quick to this guy here. Yeah, let's go ahead and talk about that one for a second. I'm just going to get a different piece of paper here. If there is no value of x in the middle, you got h of x is equal to 49 minus x squared. That means there's no x value, right? So if there's no x value, what number would go with x if there is no x value? What can you multiply in order to like cancel something out? 0. So this would be equal to 49 plus 0x minus x squared. Because 0 times anything is 0. All right. Then, a couple other things I suppose we could do here, because let's see. We're trying to figure out where this crosses the x-axis, aren't we? That's kind of the goal here. Now, there is a shortcut here I'm going to tell you about in a second. But if we go and we just write this in standard form, this would be negative x squared plus 0x plus 49. And if we divide everything by -1, are we okay with writing it like this? X squared minus 0x minus 49. Everybody okay with that? Just divide out a -1, gets rid of everything. So what two numbers would multiply to negative 49 and add to 0? Yeah, negative 7 and positive 7. So negative 7 and 7 would multiply to negative 49, and negative 7 plus 7 is 0. So we could say this is equal to the opposite of x minus 7 times x plus 7. Now, at this point, we can actually just redistribute this negative into here. And this would be equal to negative x plus 7 times x plus 7. Just distribute that back in now that we're factored. And then if you set those each equal to 0, let's see what happens. If this one is set equal to 0, you subtract 7 from both sides, and you get x equals negative 7, which is here. If you set this equal to 0, you would subtract 7 from both sides, and it would be negative x equals negative 7. So then you divide both sides by negative 1, and x would equal 7. So that is one way to do something like that. Now, if you notice, so factors here, it says x plus 7, x minus 7. That is true. It's the same thing as this, just kind of opposite of what we have. The solutions are 7 and negative 7. Doesn't change the answer. But what I want to mention here is if you have something of the form where both your first term is a perfect square and your second term is a perfect square, which these are, 7 times 7 is 49, x times x is x squared, and there's a minus in between them, that's the same thing as the opposite of this that we've been using already. If two things are perfect squares and there's subtraction in between them, you can basically square root them and write one as a plus and one as a minus in the parentheses as a shortcut. Or you can put the 0 in the middle and factor it normally. That's up to you. So let's get into some notes. All right. Cool. So starting off here. I don't see any reason why we can't finish these notes today. It's another pretty short lesson overall. So the factored form of a quadratic equation is 0 equals ax squared plus bx plus c, or in this case, if it's factored, which is what it's telling us to do. There we go. If we're factoring it, then ax squared plus bx plus c factors to, if there's an a value you can factor out, you factor it out. And then you've got two sets of parentheses. They each start with x, and then you have a minus p and a minus q, which would just be your regular numbers. That's what we did. Why does this equal 0 over here? Why is that equal to 0? What are we trying to figure out when we solve a quadratic? X-intercept, so this is all a function here. And what's the y value for every x-intercept? 0. So instead of y equals, it's 0 equals, because we're looking for when y is 0, which means whatever x is going to be the x-intercept. That's what we're going for. A does not equal 0, because if a equals 0, it's not going to be a quadratic, it would just be linear. In this equation, p and q represent, there they are, the x-intercepts of the graph of the related function. For example, if you were to take 0 equals x squared minus 2x minus 3, you can write this in factored form of x minus 3 times x plus 1, because negative 3 times 1 is negative 3, negative 3 plus 1 is negative 2. And the related graph, if you relate this to a graph, if you graph y equals x squared minus 2x minus 3, and figure out where it crosses the x-axis, you get negative 1 and 3. That's what we're doing. Same thing that we've done before. We are just happening to use factoring now instead of graphing. So the key concepts of factoring. If you have multiple terms with a common factor, you can just divide out that common factor and be whatever is left over within your parentheses. However, if you have more than just a couple factors with one common factor, you then need to use the factoring processes that we talked about. So that's all this is saying. Also, the one other thing I want to mention here is the zero product property, which is something that you have known honestly since like grade school. And you talked about it in Algebra 1. I remember that as well. That's been taught in Algebra 1. But basically the zero product property says, if you have two numbers and their product is 0, what does that tell you about at least one of the numbers? What's the only way to multiply two numbers to equal 0? At least one of them has to be 0, right? That's the only way that works. So It's saying if you have two numbers, a times b equals 0, then either a is 0 or b is 0, or both of them are 0. At least one of the two numbers has to be 0 if you multiply anything to equal 0. So with factoring, if we have our equation where y is equal to 0 because we're looking for an x-intercept, if you multiply this number here, because that is a number, it's just a number that we don't know the value of x yet. But in parentheses, that turns into a number, that turns into a number. So we're saying that either this is 0 or this is 0, or both of them are 0. So x minus 2 equals 0, x plus 4 equals 0, or both of them are equal to 0, which is why we set them equal to 0. Because if they multiply together to equal 0, one of them or both of them must be 0, and then you solve for x. So, first problem, here we go. So to solve a quadratic equation by factoring, first make sure that one side of the equation is equal to 0. This is a very familiar process. We did this with linear. We've done this with absolute value. Because setting it equal to 0 means we're trying to figure out where it crosses the x-axis. We're setting a y value equal to 0. We're basically resetting the function to have it compare where does it cross with the x-axis. We've done this multiple times with different types of functions, and now we're working on it with quadratics. So solving this by factoring, if we get this thing equal to 0, what would be a good first step here? What's a good first step? Subtract x, and I think it even tells us that right there. Subtract x from each side. All right, so if we subtract x from each side, what's negative 2x minus 1x? Negative 3x, good. So minus 3x. And then because there's only two terms here, and they both have at least one factor of x, we can divide an x out of each of them. You'll notice the x is here and here. And both 12 and 3 also have a factor of 3, so you can divide out of 3 here and here. What is 12 divided by 3? 4. X squared divided by x means that of the two x's that were multiplied together, one of them got factored out, so there's still one of them left. So 4x goes in the parentheses. And then negative 3 divided by negative 3 is what? 1, okay. And then x divided by x is what? Was it? It's just 1, right? Yeah, x divided by x is also 1. So that's a 1. However, let's see. I don't really like the way they structured this. I want you to change something real quick for me. Change this minus to a plus. Because they factored out a 3x here, which means they also needed to factor out a 3x here, not a negative 3x, which means that we have a negative 1 inside the parentheses instead of just a 1. Not a huge fan of how that worked. But this will make more sense, I think, for grouping things. Because if you factor out a 3x, then the 3x is what ends up on the outside of the parentheses. And then the leftovers, when you divide, 4x minus 1 is what remains inside your parentheses. So that should be a plus. That should be a negative 1, 4x minus 1. Then you set each of these factors, 3x and 4x minus 1, set them each equal to 0. 3x equals 0. What's 0 divided by 3? 0. Okay, so divide by 3, you get 0. And then over here, solve for x. What do we do? Add 1 to both sides, so 4x equals 1. Now be careful. Some people kind of made this error on their Unit 2 test. What are we dividing by here? We're dividing by 4. What's 1 divided by 4? 1/4. Good. So 1/4. So 0 and 1/4 are the two x-intercepts of that function. Any questions here before we continue? Kind of the starting point for factoring. All right, let's keep going. Example 2, factoring a trinomial. Hey, we did this already. Let's do it again. Subtract 18 from both sides. What is negative 9 minus 18? Negative 27. All right. What two numbers multiply to negative 27 and add to negative 6? What What is it? -9 and +3. Good. So -9 and 3 are the two factors we need. -9 times 3 is -27. -9 plus 3 is -6. So we're going to get x plus 3 and x minus 9. And if you set those both equal to 0 and you solve for x, subtract 3 from both sides here, x equals -3, add 9 to both sides here, x equals 9. And that's it. So for basic factoring, that's all you got to do. All right, now we've got a couple of word problems, and then we're going to get into some more factoring after that. And there are going to be some special products and things like that after that, with the potential for imaginary answers. Ooh, okay. So we got to incorporate the thing we learned on Thursday. So solve an equation by factoring. Here we go. The equation d equals vt plus 1/2 at squared represents the displacement, d, so that's our y value, of a car traveling at an initial velocity v, so v is the initial velocity, where the acceleration a again, is a constant over a given time. Time is t. So d is our y value, traditional y value. T is our traditional x value. That's what we're looking at here. Find how long it takes for a car to accelerate from 30 to 45 miles per hour if a car moved 605 feet and accelerated slowly at a rate of 2 feet per second squared. Okay, that's a lot going on. So describe the task. Well, we need to figure out, let's see, how long to accelerate from 30 to 45 miles per hour. Let's see. After moving 605 feet at 2 feet per second squared. I'm just going to summarize what it's asking us to do. We need to, first of all, in terms of how will you approach the task, approaching the task will involve substituting in for any variables that we can, right? We know that we're not going to have the time. How do we know we're not going to have the time? What's that? Doesn't give us the time, and that's what it's telling us to figure out, right? We don't know what t is. That's the whole point of this. So how about this? Solve for t. Because we're trying to figure out how long. How long is it going to take? That's time. We don't know time. We're solving for time, which means we should have information that will allow us to figure out what in terms of our equation up here. What things should we have provided to us? Distance, velocity, and acceleration, right? We should know distance, velocity, and acceleration. So, so we have distance, velocity, and acceleration. Or sorry, displacement, not distance, displacement. So, and then we're going to substitute and factor and solve. Like that's kind of the whole point of this one. So, what is the velocity in feet per second? Talk about it. What was the initial speed of the car at the beginning of this? It's going from what speed to what speed? It's going from 30 miles an hour. So that is the initial velocity right there. So that's V. Correct. No, it is not. We are in miles per hour. We need to convert to feet per second. So we also need, so we're going to convert miles per hour into feet per second. Oops, you can't see that. It is. Convert miles per hour into feet per second, because that's going to give us the velocity. Now, the velocity that we need is not 45 miles per hour. The velocity we need is 30 miles per hour, because that's the initial velocity, and it says that initial velocity is V. So we need to figure out the initial velocity of 30 miles per hour into feet per second. So let's think about this. So we got 30 miles, and we've got hours here. We're going to do some unit conversion here real quick. All right, this will be fun. So we need to convert miles into feet, and we need to convert hours into seconds. So we have to convert both units of measurement here. So if you remember back to unit conversions, we can multiply by a conversion factor in order to make this happen. So the units we're looking at are, we need 1 mile here, because the miles need to cancel out with miles here. How many feet are in a mile? Because we're trying to go from miles to feet. 5,280. So we're going to say 5,280 feet here. All right. And what's going to happen is you can cancel out units just like you can cancel out numbers. So the miles will cancel out. And then we also need to convert from hours. So we're going to have 1 hour into number of seconds. How many seconds are in an hour? Anybody know? Yeah, 3,600. And the reason why we can figure that out quickly is because if there are 60 seconds in a minute and there are 60 minutes in an hour, you're going to multiply 60 by 60, right? 60 seconds per minute, 60 minutes per hour, 60 times 60 is 3,600. So the hours are going to cancel out with the hours, which will then give us 30 times 5,280, which is 158,400. 158,400, and then we're talking about feet over 3,600 seconds. So this is miles per hour in feet per second, and then we're going to divide in order to figure out the unit as opposed to like all of the numbers. So we'll divide that by 3,600, which is 44. So 44 feet per second. That's the initial velocity. That's what 30 miles per hour. So if you're going 30 miles an hour, every second you're traveling a distance of 44 feet. Okay. So what is the velocity in feet per second? 44. Cool. So that is equal to V. We still need A though, and we still need D. Now displacement is how far the car travels, because you're displacing from one place to another. So what is D? 605. So D equals 605. And then what is A? What's the acceleration? It says A is acceleration. Yeah, 2. So A equals 2. All right. So now we have to solve. So we're going to substitute these things in and solve. So I'm going to go back up here real quick. And I'm going to write in, not that far. Go here, and let's say we have D, so 605 is equal to V, 44, times T, plus 1/2 times A, which is 2, times T squared. Just like that. Now that we have the numbers we need, we can drop them into the formula, and then we can solve it. So we got a couple things to do. I would recommend getting your T squared first. What's half of 2, though? 1. Okay. So T squared plus 44T. And then we also need to subtract the 605, right? we have to subtract 605 to get the thing equal to 0. So 0 over here minus 605. All right. Cool. We need two numbers that multiply to negative 605 and add to 44. Well, this might be helpful. I'm going to look for 605 on here. And then I'm going to figure out the two numbers that I'm looking at and see if they actually work. So let's see, 605. Anybody find it? 605 anywhere to be found? If it's not, then one of our numbers is probably bigger than 50 if we can't find 605. I'll be honest, I don't see it anywhere. Anybody see 605? Is it in the multiplication chart at all? I don't see it. So how about that? How about 55 and 11? It's not on our table. It goes to 55. So 55 and 11 would be a couple of numbers that would multiply to 605. And look at that. They're 55 and 11 are 44 apart. So that seems to work just fine. So this is going to be 0 equals t minus 11 times t plus 55. And so the time, if we set this one equal to 0 and solve for t, what's t equal? Set that equal to 0, solve for t. What do you get? 11. So t equals 11. If you set this one equal to 0 and solve for t, what do you get? Negative 55. How long does it take for the car to accelerate from 30 to 45 miles an hour? $11 seconds. Just 11, right? Because that doesn't make sense. That's negative 55 seconds. That can't be right. Now, if you're to graph it, it would cross the x-axis at both 11 and negative 55, but that's the only one that actually makes sense here. So how long does it take? It takes 11 seconds. So you can see with word problems, it definitely takes a little bit longer. Because you got, well, in this type of problem anyway, because you had to do a bunch of conversions. Write an argument. Well, okay, first of all, we know it's correct because it's positive and not negative. That would be kind of the argument here. One last question before we move on to the next one. Why did you not use the 45 miles an hour to solve this problem? Yeah, it was the end velocity, which is not part of the formula. Initial velocity is. Okay. Let's move on. I will put the check step in the answer key online, but I'm not going to deal with it right now because let's move on. All right. If you have a number in front of your x squared and you want to solve it, we talked about this one a little bit earlier, about this style of factoring. And you'll notice they don't actually tell you how to factor from here to here. It's just like, oh, here's the quadratic. Hey, there it is factored. I would recommend using the slip and slide method, and I would want to do this over to the side. And actually, let's do it here on the side because I want to do the next problem here on the side. So if we do a times c, we're going to take 3, multiply it by negative 2. What's 3 times negative 2? Negative 6. Okay, so I'm going to say 0 equals x squared plus 5x minus 6. Just like that. Multiply the first term times the last term. We need two numbers that multiply to negative 6 and add to 5. That would be positive 6 and negative 1. So that's going to be 0 equals x plus 6 times x minus 1. Now, both of these need to be divided by the original value of a, which is equal to 3. So if these both get divided by 3, 6 divides by 3. What is 6 divided by 3? 2. So 0 equals x plus 2. Now the slide part of slip and slide says if you have a denominator, 1/3 doesn't reduce, we have a denominator that moves in front of the x there, which means we have 3x minus 1. And you'll notice right here, we have x plus 2 times 3x minus 1. The order of the multiplication does not matter at all. X plus 2, 3x minus 1, we got it factored. And then if you set them equal to 0 and solve, you get x equals 1/3 and x equals -2. All right, let's do this one right here down here. And then we got, I think we'll be able to finish this. So do any of the, well, actually, what do we have to do first here? Before we even start factoring, what do we have to do? Set it to 0. Subtract 13 from both sides. What is -27 minus 13? -40. Okay. So we're going to go over here. We're going to say 0 equals 4x squared. Put it in the margin over here. Plus 12x minus 40. Is there a common factor between all three of those? 4. Yeah. So let's divide out the 4. That'll make this a lot easier. So 0 equals 4 times x squared plus 3x minus 10. Because the 4 can be divided out of all of them. And all of a sudden, there is no number in front of x squared, which means we just need to do regular factoring here. We need 2 numbers that'll multiply to a -10 and add to +3. Yeah, 5 and -2. Plus 5 minus 2. Which means if we set that equal to 0 and solve for x, you get -5. So x equals -5. And if you set that equal to 0 and solve for x, you get 2. Which is kind of nice. You don't have to take into consideration this 4 in any way whatsoever. What's that? Well, because it's part of the factor. You don't use it to figure out the x-intercept. But if you were to graph it, you would absolutely need it because it would make it a lot narrower. Yeah. So in terms of, because the only thing we really care about is the x-intercept, but if you were to graph it, you'd need to take into consideration that there is a 4 for that a value. So the x values here would be -5 and 2. All right. Now, there are some shortcuts that we can use, and I'll mention those on the next page. They're written at the bottom of this page, but let's just go ahead and turn it and start working with it because there are some things that you need to see here that are going to be a little bit weird looking, especially when we start talking about potential for imaginary numbers, which will happen, I don't think, on this problem. So here we go. This is actually a lot like the one that we saw in the warm-up, where we have 2 numbers that are being subtracted. They're both perfect squares. And there's a subtraction in the middle. So this 81 is the same as 9 squared. X squared is x squared. So if you square root each of these, at this point, square root the 9 squared, square root the x squared. Don't put square roots over them because that's not like mathematically precise. But this will factor from a squared minus b squared into a plus b times a minus b, which is the opposite of what we did last week, which is what we did in the warm-up. So this is going to be 9 plus x times 9 minus x. And then to get x by itself here, you'd subtract 9 from both sides, and x equals -9. Here, you can just add x to both sides, and then x is equal to 9, so you get +9 and -9. That's it. So there's a couple ways to do this one, this next one, although, gosh, I actually don't like the idea of using factoring to solve this. Because look on your multiplication chart real quick, find 529. Tell me what you notice. It's a perfect square. In my mind, there's no reason to write this equal to 0. Because you already have x squared by itself, you may as well just square root both sides if you know it's a perfect square on both sides. And so you could square root here and square root here. And when you square root, we talked about this on Friday or Thursday. If you're solving for a variable, x has a positive and a negative root here. So it's going to be positive and negative what? 23. Now, what they wanted you to do, I'll just do this very quickly, is they wanted you to set this equal to 0. X squared minus 529 equals 0. This would be a squared minus b squared. So if you square root both of them, you get x plus 23 times x minus 23 equals 0. Set those both equal to 0 and solve for x, and you get 23 and negative 23. However, it's already a perfect square. It's already equal to a squared x squared, so just square root both sides. Solve by square roots on that one instead of factoring. This increases the amount of work you have to do. This is the most efficient way to do that. Okay, let's keep going. All right, next, get the thing equal to 0. So they're doing two things. They're subtracting 26 from both sides, which is negative 48, or 26y from both sides, which is negative 48. So minus 48y plus 23. Subtract 13 from 23. What do you get? 10. Okay. So is there a common factor between 16, negative 48, and 10? 2. Okay. So divide out of 2. Let's do the math over here. So we're going to say 2. So 0 equals 2 parentheses 8y squared minus 24y plus 5. And then we're going to do the slip and slide factoring method on the inside of the parentheses here. Now, at this point, I am going to ignore this 2 for a minute, but we'll bring it back at the end. So we're going to get y squared minus 24y, 8 times 5 would be plus 40. So we need two numbers that multiply to a positive 40 and add to a negative 24. Oh, you know what? I messed this up. I subtracted 13 instead of adding 13. Whoops, that's 36. Silly me. Okay, cancel that out. All right. This one can actually be factored a lot quicker. If you notice that the first term and the last term are perfect squares, you can try something. So let's think about this for a second. What is the square root of 16? 4. What is the square root of 36? 6. What is 6 times 4? What is twice the amount of 24? That's the middle, right? Okay, so think about it this way. If you have a perfect, if you notice, and if you don't notice it, factor out a, what, 8? No, that doesn't divide by 8. Factor out a 4 from each of these. Those all divide by 4. And then do the slip and slide method, you factor to be fine. However, if you notice you have a perfect square here and here, 4, 6, multiply those two together, multiply the square roots together and double it. If it equals the term in the middle, that means you have a perfect square trinomial. Meaning, this is the same over here as 4y squared. This is the same over here as 6 squared. And this is the same as 2 times 6 times 4. But let's be a little bit careful with that because it would be one's going to be positive and one's going to be negative in order to get to negative 40. Actually, yeah, one will be positive and one will be negative. So let's go with, I don't know, let's go with 4y here minus 6. Because this is actually over here in parentheses, make that a negative 6 squared in the parentheses because negative 6 times negative 6 is positive 36. The reason why we need to make it negative is because the middle term is negative. If the middle term was a plus 48, everything would be positive. So what we end up with here is 4y squared, or 4y minus 6 squared, just like that. That's what it would factor. You can use the slip and slide. This is a bit of a shortcut. And if you solve, let's see, you just set one of these because it's two of the same set of parentheses, add 6 to both sides, divide by 4. 6 divided by 4 is what? That'd be 3 over 2, so 1.5. All right, I want to talk about this last one. I'll put this check step in the notes for online, but I want to talk about this last one real quick. Now, this last example says x squared equals negative 144. Now we know that a square root cannot equal, or you can't square root a negative, but now we can because we learned about imaginary numbers. So if you have something that is like this and you set it equal to 0, which you could just square root both sides here and get your positive and negative 12i, I would recommend that. But in terms of both of these being perfect squares, we don't have an a squared plus b squared equal to anything, but we do have an a squared minus a b squared equaling something. And so this is going to be the same process as a squared minus b squared equals a plus b times a minus b. So if you square root 144, you get 12. So positive and negative 12. But if you square root negative 144, you have to factor out that square root of negative 1. So that would be 12i and negative 12i. So x is equal to 12, or x plus 12i, x minus 12i. Because if you're square rooting this, the square root of negative 144 would be positive and negative 12i. So if you set those equal to 0 and solve for x, this x is going to equal negative 12i, and you'd add 12i to this one, and this x would equal 12i. So you can solve with imaginary values. That is a possibility. So if you end up with something and you're like, oh, I'm trying to square root a negative, well, treat it like we did on Thursday. Factor out the I and just factor it like we did with that. So just include the I with your answers and you'll be fine. All right. Your assignments. We got 1 through 43 odds. I don't believe there is any graphing on here. It's just a lot of this is pretty straight up factoring. Some of it will include some imaginary numbers here and there. And then tomorrow, we're going to begin. Actually, tomorrow's lesson that we're going to start is going to take us at least 2 days. So this will be due on Wednesday, okay? This is not due tomorrow. It's due on Wednesday. And because this is due on Wednesday, listen up, please. 3-3, you can turn in tomorrow. Okay? 3-3 can be turned in tomorrow. Does not have to be in a day. This one needs to be in by Wednesday. I'll see you tomorrow. Have a great day.